Morning.
Hey, good morning.
Hey, good morning. You're new here, right, Subha?
Yes. Yep.
Yeah. Hey,
Yeah.
Dubai.
You want to turn on the video? I was prepared last time. I don't think I'm prepared.
Oh, no,
you
don't. You don't have to do that. I just do that because I always kind of feel like if I don't show my face, then nobody sees anybody on YouTube. So then it just kind of feels kind of sad. So I always put my face out there.
Nice. Thank you.
If I can. I also have mornings though too, like where I don't want to show my face, and I'm just like, you know what? No, I'd rather just not, because I look horrible, or I need a coffee, or want to eat, and I don't want people to see that. So that's probably what it is. So I get it. All right. I think let me go ahead and get the usual stuff out, and I'll share my screen. Amelia, are you gonna read today? Just asking.
I can read Agro. By the way, Subha, I was hoping more people join before I introduce Subha. Subha is my colleague. We've been working together for 4 years, 5 years now.
Yeah.
She's technically skilled and brings a lot of value.
Yeah, Mulia.
Yeah.
That's awesome.
Yeah. Akansha is here.
Happy to have you.
Thank you. Thank you. Happy to join. In fact, lucky to find this group actually. Yeah, I have been in the same motivations for long, but not finding time. So yeah, I think at least I haven't finished the chapter 4, but at least I got 2 pages in this all long years. So yeah, I'm happy about it.
Oh, that's great.
Started somewhere.
Yeah. I mean, and honestly, like I feel so we're doing this chapter, and we're doing this book and all that, and I think that's great. But I also just want everybody to bring creative ideas, to this, because obviously, the system design interview is different from just reading a book, right? Like if you read a book, the expectation should not be, oh, I read this 1,000-page book here, now I can ace a system design interview.
No way.
Yeah.
No way. I get it. I think there is a course that grokking system design or something, which is very famous. Yeah, I was initially thinking to sign up for that, but yeah, still thinking about it.
Yeah.
That's on Educative, right? Educative.io. Yeah.
I just heard about it.
Yeah, but so basically what we want to do is kind of between chapters, instead of just reading all the time, between chapters we take up a design question, and kind of one of us can either, like, we kind of last time we discussed what the Twitter.
Nice.
Yeah, so yeah, similar. So basically we kind of interleave both the design questions and chapters.
It's good actually. Yeah. Makes sense.
Yeah. And just it would be also good, like, and I think we're doing it anyway, but just to also continue to review more, because I think that stuff sort of helps a lot. It's just a lot of this stuff is very densely packed, like as they like to say, and I think if you have like a good basic understanding of like technologies or the things brought up in this book, that's a good first start, like knowing what Avro is, or a protocol buffer.
Vijay, you don't need to remember everything, I mean, even the very senior folks or distinguished engineers, they don't know everything, and they don't know all the details. If you ask them even about Avro or anything, they can tell you either they have not used it, or they will tell you this is what they know, like 1 or 2 liners. But nobody knows all the details.
That's true. Yeah. No one knows all the details, but I guess like just being, more and more, a little bit more like,
I think
understanding of stuff. Yeah, would be great.
Exactly. The high level concepts we should be familiar with.
Right. So to my point, right. So I was talking to somebody yesterday about, it was like, I was looking for, some extra work, and I was talking to somebody, on LinkedIn, And they were kind of going over like their stack and everything like that. And I just kind of happened to point to them, the other day, like, oh, they asked me about my stack. And so I happened to point them to, the Alex Shu article or the post that, I tagged some of you on, and I can show you that. So this post, let's see here, I'm going to drive down because it's probably deep down. Oh, by the way, two things, right? Like, so my friend Jason is working at Neo4j, and I guess like he was saying that he's going to be doing a conference, and we already talked about Neo4j, like in previous chapter. So I might go to that conference just to check it out because like, it was kind of cool. Like, and he said that they're doing some fun workshops. So this would be good for just exploring graphs. So just throwing that out there. If anybody else wants to go with me, let me know. I'll probably get you a discount. And then the other thing that I wanted to just talk about was this diagram here that I kind of, again, like I saw on Alex's blog here. Let me see if I can zoom in. Okay, so yeah, I was talking to somebody yesterday at a different company about like their architecture, and then like we were going over monoliths versus direct access, and then gateway aggregation layer, what the gateway pattern was, and then they happened to say that they were a federated gateway using GraphQL pretty much as their technology. And so like when I was saying, oh, that's really cool, like I've been kind of like studying, things like, these design patterns, and then, talking about like the things that we came up with in this group yesterday, like, or the other day was like protocol buffers and just using GraphQL, RPC, gRPC. He was like, yeah, that's right. That's exactly right. Like I was confirming a lot of the stuff that I had picked up. So people do know. That's actually my point. Like if you start looking for these things, you will find it. I guarantee you, right? Like I think we don't really know it that well because like, maybe we'd never had to use it before. But as you start reading it, you start instantly seeing like the stuff appear. I don't know what it is. Maybe the universe gives it to you too, because you've been seeking it, like that kind of thing. But like you start
I get
seeing
you.
it more.
So basically, when you don't understand the jargon, right? So we kind of tend to, our brain kind of is wired to only see stuff that you understand and and things
Exactly.
that you don't know, it's kind of goes into a blur. So as you know more, more details come out. Yeah.
Correct.
Hey, can we discuss that? Or do we the thing you shared, Vijay?
This one? Yeah.
Yeah. It's a good thing.
So this was about Netflix, and this is something that so when I joined Beachbody last year, which is my present company, right? Like I was working with two people. One was an engineering manager, and the other one was a technology director. And they both kind of were talking about like this, right? Like they were talking about like how they wanted to move, their monolith to something, more, tame and better, like one of these last two pictures here. And so there's a lot of talk about the gateway pattern, but I felt like people didn't really know what the gateway pattern was. And, I was kind of like bringing it up in meetings. Because like a lot of those people, including the technology director, come from like a Java background. But if you're a JavaScript developer or React developer, you're not going to know like, the design and solid patterns like off the top of your head. Because if you haven't dealt with it, then you're not going to know. So they were trying to find people who knew those things and, like try to basically just kind of give like, they were trying to give a high level of it, but I felt like there was something wrong with the way they were explaining it because they were explaining a different pattern. So I was like, oh, wow, this is the gateway pattern. So I tagged them below, as I tagged you all. And this is kind of like, again, like if you're interested in this, I highly recommend reading anything Netflix blog, Netflix API, because this is like the gateway pattern. Basically, the idea is that, most the way the Netflix site evolved was it first was a monolith, right? You would just access the site directly and it had like tons and tons of code. It was a single Java, WAR file. So probably on Java Spring with a Rails app. So everything was just baked in. And then they decided to split it into like microservices. And so then, their website like started connecting to all these different microservices. And this looks more like Beachbody's architecture today, honestly. Like we have just tons and tons of calls to tons and tons of APIs. And so you get back like, all of these different payloads that are just kind of like wild and like unmanaged, right? So you need some kind of separation, which is a gateway, right? Like a door or a fence or a gate. And basically that makes it so that like you make less requests and then like the gateway can talk to the servers essentially and return back like a more solid, like better, like defined response. And that this can be done with the help of things like GraphQL or, like the stuff that we were talking about yesterday, the protocol buffers. And then you get like these nicer payloads that don't screw up like the experience for the other side, as well as it's more developer friendly as well. And then this is kind of like the newest one, Federated Gateway. So, this is kind of like, it says, as a number of developers grew and domain complexity increased, developing the API aggregation layer became increasingly harder. So GraphQL Federation, right, allows Netflix to set up a single GraphQL gateway that fetches data from all the other APIs. Why do you think Netflix uses GraphQL over RESTful? So that's this beautiful little gem I wanted to share with you all. Maybe discuss at some point. What do you think?
I mean, we can just discuss now only, right? So we have, I have seen, so this seems to be a slightly different, the third diagram, right? So the second is a natural evolution, right? The first you start when your service is small, you start as a single service. And then as you introduce a lot of additional functionalities, additional services are brought up under the same, public service bucket, right? So basically, yeah, it becomes a microservice architecture over time as you add more functionalities. So the third one, I think, is like he says, it's optional. And there are two ways to do it, right? So if you are an SDK kind of a service, right, for a builder to use your service, if they have to remember, like if they have to basically maintain this directory of services, the microservices, I think that's probably not great. They would want a single point, single domain, and they want this complexity abstracted away, right? So in that case, yeah, this gateway thing that basically ties all of them together, hides that complexity, probably makes sense. But I think in this context, what they're saying is they are basically exposing a GraphQL kind of service that is fronting a REST kind of a service, which is basically, I think the intention behind making it GraphQL is to make it, less network bandwidth consumption. Like make the payloads smaller and
Right.
make it faster. The latency is faster. I think reduce the network bandwidth dependency.
Right.
Right.
And I want to continue to encourage the conversation here. But I'll just say one thing, like, I feel like you all, if you don't have like much experience with GraphQL, you should check it out. I think you'll be like surprised by some of the things that you see there, especially like how it goes hand in hand with the things that we've been reading so far. I can recommend you like maybe one of these courses here. Like I had been going through it. This one was just 4 hours. So I know I said just 4 hours, but honestly, like that's like, 2 days for me, like if I'm going at my pace. But, you know, like, it's really good because like I can kind of show you like some of this, right? Like you're making the query here, but you're kind of like creating like this, you know, schema or structure that essentially goes and doesn't return back like everything from the database. Instead, like you get back like smaller and like more concise data that you can work with. Like you don't have to make tons and tons of machine requests, kind of like what we were talking about over here to like, you know, you're basically kind of like reducing the payload, and it does it in a way that, you know, follows this kind of, you know, these kind of protocols. So it's just ultimately comes back like in the smaller and reduced message, which is, you know, great for the server and great for the client. So
It will speed up your application using,
yeah.
if you use REST API versus GraphQL. So
No, but
another thing, sorry, go ahead, Amal.
Go ahead.
no, so but using GraphQL is not necessarily faster in the sense it optimizes for the bandwidth, like network, like for example WhatsApp, right, where we're basically dealing with mobile networks. So I think there it probably makes sense. But on the server side, right, because the schema is so open-ended, it depends upon, basically the load is now on the server to validate the user request, because with REST you have a more defined API, and basically there's a defined response and request and response schema, right? But with GraphQL, it's open-ended. The client can request any random you know, attributes, and it's on the server to validate whether this makes sense, and then kind of fetch whatever. It's hard to optimize for performance.
So like this, like it becomes a sort of an interview question here. Like when would you, so you're designing and in any API, and suppose you're in the system interview question, like in a Twitter question we discussed, what API calls would be used, REST or versus GraphQL? So how would you answer that?
Yeah.
So the answer
ahead,
to that
Karthik.
is really very
That is
simple,
your hand
right? GraphQL you will only use when the client is a mobile phone or maybe an IoT device, right? Connected some kind of IoT device that needs to consume. The reason why they are reducing the payload is to limit the number of API calls, right? Like they want to get the required information at that point with a single network call, right? So that hop is what is the main point of GraphQL here. Now it adds another layer of complexity, like Amulya mentioned, because you need to maintain those servers. That's another single point of failure for you, right? Everything goes through there, and behind sits your data services, truly. So you would not expose GraphQL for API integration, public-facing APIs, or even SDK will not consume GraphQL. Only devices or IoT stuff would, like, you know, consume GraphQL, and of course, the front end deployed on these devices, right? Front end applications like React, Angular, all you. The intent is to keep it keep low on the network calls, get with a single network call as much information as they want. So it doesn't really mean reduction of payload. It only means query only the related information if you want from the data services. Think of it like a SQL, where instead of doing select star, you would only want, let's say, 5 elements, but the table has 100 elements. You wouldn't, it's not optimized to get everything. So exactly what is happening at a service level, right? Get the relevant information.
Karthik, yeah. So Netflix, most of the people are watching Netflix on their mobiles or televisions, right? So I mean, the IoT, they have less traffic as on mobile or other devices as compared to people are watching on the big screen. So why do you think will they be using GraphQL over here?
So like I said, like the space in a, for example, let's say in a smart device like TV, the space that you can install the app requirements are less. The RAM requirements are also less because it needs to process the codec on the video. So these kinds of environments, they wouldn't want to make multiple networking calls, API calls to get, let's say you're logging into Netflix, your favorites are going to show up, but that favorite could be multiple microservices. One could be a recommendation engine behind the scene by user, one could be, you know, new releases and stuff. So they don't want to make multiple calls to populate that particular dashboard, right? It doesn't make sense because every call, like, you're going to have some amount of spinning there. So what here is the use case is that, let's say they have exposed a GraphQL, this particular, whatever client is in the TV is going to talk to that GraphQL, quickly get that information. It's not necessarily getting all the information, 100 recommendations, right? Top 5, top 10, only relevant. And then as you go paginate, they're going to do another query. So the point is to get as much information across different services, right? It might not be very visible for us when we log in, but like, everything is a separate service by itself, right? That's the whole point. Now, again, GraphQL and API Gateway are two different concepts. I think there's a bit of, overlap, but not necessarily the same, right? API Gateway brings way too much detail. Like one of the things what Amelia mentioned is service virtualization. Go to a single point and try to traverse multiple APIs rather than going different addresses, right? On top, it brings capabilities or different capabilities on a microservice level. This thing, rather than application developers have to handle at each microservice, everything is abstracted at the API gateway level. Like, for example, rate limiting, right? Like, okay, like a particular API key, you don't want them to, query your API, like, let's say 1,000 times in a second or whatever, right? So rate limiting comes, bulk heading patterns comes, you can apply security there, authentication authorizations. Also, you can do the complete observability, right? Every call tracing, everything can be applied and it can be pushed down to the API gateway level, which has that capability, so that we don't have to write at each microservice and inherit the same concepts, right? Oh, every service has to be authenticated, every service, right? So everything can be abstracted there, whereby the traffic on your service itself will not get pounded. Let's say an unauthenticated user is coming, so it will get like, rejected right away at the API gateway level. And this is not something new. It's been there from the days of SOA services, right? There used to be service virtualization. Now it's API gateway and service mesh. API gateway handles north-south traffic. Service mesh handles east-west traffic. So east-west traffic is within your data center, service-to-service communication. North-south is like generally any communication that happens from outside in the public internet via your DMZ comes into your network, if that kind of explains.
Yeah, thank you.
Yeah, great explanation, man. That was great.
So in this Federated
go ahead.
Gateway last picture, what are those dark blue boxes over there?
That's a good question. I wanted to see if I could,
yeah,
like find a bigger link for this, like, because what I was trying to do here was, I guess maybe it's this one. This is the image source.
I would assume those are all nodes because your API gateway has to be a distributed gateway, right? You don't want to have like single point of failure there as well, right? Generally, typically all distributed systems now have a control plane and data planes. So data planes handle actual this routing, all those capabilities, and control plane is more like administration node to control those data planes. So I'm assuming that's a distributed API gateway, right? Most likely it would be the same way service meshes are also distributed. Yeah.
I think this is, yeah, you're right. It says DSG. So I'm going to share this with you all first in this chat here, and then I'll also paste it to the usual Discords and WhatsApps.
Yeah, I think that's what it is. So basically, maybe if your API gateway is global and it basically probably is redirecting to regional specific, specific traffic to each node. It's basically the node is part of the gateway. It's basically distributing the load among multiple gateway nodes.
Yeah, so think of it like an agent kind of a thing sitting in each of your VPC. It could be one or many, and it's all hooked up to the main control plane. So any traffic that comes, it can get distributed based on pretty much like if you guys are familiar with Routed 53 in AWS, like you can do based on geo, you can do based on IP. So different balancing mechanism that you can apply, but default is round robin across the system, right? Some services could be in a different VPC. and some other service. So it has the capability, intelligence to, in fact, parse the URL. You can apply a lot of routing algorithms where it can go. So it's complex, right? That's why it's there, but it does a lot more. It even generates your whole observability pattern, the metrics, like for example, a particular service, how many times got invoked, what is the response time. You can have all those metrics generated out of the API itself in a centralized place, right? Rather than having to build system monitoring, auditing systems. If we were to go like when the API gateway was not there, we would come up with a framework where we capture all this information to look into it, right? So those things can be completely pushed down to the API gateway level, and we can just focus on building the business logic for the microservices.
I think here specifically, it looks like they have grouped services per domain, like what Vijay was saying. At DGS is domain graph service is what it looked like in the description. And
Right.
Yeah, they have grouped services specific to each domain, like movie production. And
Right.
Yeah.
I recommend reading this for everybody. And then I'm going to reach out to Tejas. He actually connected with me on LinkedIn. So that's actually really great. So I'll ask him some questions after I'm a little educated on this. And, if you ever want to, send some questions to me, we can kind of like put it together, and get some better explanations, because that might be fun too as well. Like just getting more educated about this kind of stuff. So cool. Thank you for checking this out. I feel like at this point, right, we should probably use this to kind of go back and continue through this chapter. And then maybe next week or so we can pick another thing from somewhere one of the people that we look at, like Alex Shu, or anything on LinkedIn. Just bring it up, because it'd be fun and more helpful to talk about those things in parallel. The more you see it, right, the more you remember it, and it kind of comes alive to you, the universe, right? So that kind of thing. So if you have extra examples that you find outside of this book, I think that's only going to solidify what you learned here. Okay, so let's see here. Last time, I think we left off on Avro and dynamically generated schemas, but keep me honest here.
yeah, that's correct. Yeah, I remember that.
Okay. All right. So Amelia, you want to do it, or?
I think we should leave Avro to Ramya. Let her complete, because this is essentially the the Hadoop, the data analysis kind of. I think, if Akanksha is comfortable, she can finish it. I can talk about the following topics.
Sure.
Yeah.
Sure.
Oh, I did not read. Sorry.
Okay. Yeah, I think we can just wait for Ramya next class to finish up on that. Basically, it's just 2 subsections, right?
Yes. Yeah.
Can we skip to the modes of data flow? I think that.
Sure.
Yeah.
This one.
Yeah.
Okay.
So so in this section, so Arthur is talking about different types of where do you see the data transfer, right? Where is the need for this encoding? The 3 main use cases are writing to a database and reading from a database. Most likely it's not the same processes that are doing it. So then there is that's where this question of compatibility and evolvability matters. And same applies to over the network calls, the service calls. If you go, there are 3 bullet points there. Yeah. So the next page. Yeah. So these are the 3 places, like the data writing to the databases and reading from them, and then the service calls and asynchronous message passing. So by asynchronous message passing, it's kind of a hybrid of the 2. So where the call is sent by one process and read by another process, but there's a message broker involved. So the advantage when a message broker is involved is that when the receiving process is down or some, is not available, then the call doesn't fail right away. Basically, the message is persisted somewhere where it can be looked at or retried for, at a later point of time. But yeah, that's the three places where the data flows between processes. So next section, they talk about data flow through the databases. So here, so the main idea here is that with databases, we have to remember that data outlives code. So at any given point of time, right, like there's a particular version of code that is running, but data, if you write it like today, the same data exists 5 years down the line. So you have to remember that the backward compatibility and forward compatibility tenets are much more valid when you're talking about data encoding. Yeah, so that's the, so yeah, with databases, you have to basically, that is a tenet that you have to keep in mind when you're designing your models. So yeah, so I think, what else did I underline? Yeah, so one thing is, it's a little tricky to keep the think about, so in previous places, right, where we in the previous sections, when we talked about backward compatibility and forward compatibility, we were only talking about whether we can read that data, right? So whether the newer code can read older data, or older code can read newer data. That was the goal of the previous sections. But with databases, what matters is that it's the definition slightly varies, the goal of the design slightly varies, in the sense that when older services are reading the newly written record, and let's say there are some new attributes added to the record at some later point of time, but then the older code read it and it did not know about those attributes and it tried to persist, then there is a risk of losing data, because the older, when you deserialize data, your older code models did not have those attributes, so it completely ignored them, and then when you try to persist, you lose data. So that's it's not a hard problem to solve, but when you're talking about encoding in databases, you have to remember that while persisting, the data is basically the unrecognized fields are not dropped. Basically, you ignore them while deserializing, but don't lose that data when you're persisting. Any questions so far? Did I make sense? But that's what. So it's basically it's their. I think the sections I think, yeah, there's a diagram. See, that's that. Yeah. So that's the diagram that they're talking about in that first diagram, right? So yeah, no, the middle one is the person class. It has username, favorite name, and interests. But let's say the photo URL was added later, right? It was a newer attribute that was introduced. And when you read it into an object, the photo URL was dropped because it's not recognized. And when you persist it, you lost that data. So yeah, so you have to be, I think, so the author says that most of these, the database, those mapper kind of a thing, the libraries that you use to persist or have this logic baked in, but that's something when you're designing such a library which takes care of persisting data to the database, you have to remember that there might be unrecognized fields and you have to persist those. Yeah, think that's what there is. Yeah, different values written at different times. see here, he talks about the one in italics. The observation is that, so with the database, it's a specific concern that the data is long living, right? So there is so next they say is rewriting data into a new schema is so if you have to rewrite data into a new schema, it's expensive for the databases. But if you are doing it, then it probably makes sense to kind of standardize it for future readability purposes. So let's say you have introduced some attributes over time, and the default behavior that that a library can do is persist it with null, right? Like, but if you have more, if you want to make it make a particular field required, right? Let's say when you are rewriting the schema, then that is an opportunity for you to optimize on the data model that you want. So basically, you have to you can redefine your required and optional fields more easily when you're rewriting, because from that point of time, that becomes the base from which the data will evolve, right? So I think, that's that. So I think he talks about LinkedIn's document database uses Avro. So I don't know. I think why they use Avro. I think Avro is mainly used in Hadoop kind of data analysis kind of applications. I don't know if that's what Espresso is. But yeah. So, and then next is, I don't know what that Espresso is.
I was just like doing a question, right? Like that's one thing you can ask the Google engine, right? A question, and it'll tell you like, hopefully the answer. But so I asked, why does LinkedIn use Espresso? And so I found this article. And so I just opened it in a new tab if we wanted to kind of look at it later. So, but I'll put this in the chat as well. A lot of times, like when I feel like, why does somebody do something? I write that same query in Google or whatever, right? And usually there's an answer.
Yeah, I think Avro, the intention of Avro is to basically keep the payload small, and it makes probably sense for a Hadoop kind of, a batch processing where they're processing petabytes of data, and you want to optimize on the storage. I don't know if LinkedIn's document database is such a thing. Okay, so we can read up
Come
about
back to it. Yeah.
So next is REST and RPC, so data flow through services over the network, right? So I think most of us are familiar with the REST services. It's basically transfer of data over HTTP. It's basically as REST is all about resources. So we talk in terms of resources, like getting a resource, updating a resource, deleting a resource. So the language and the way we think about network basically the communication is in terms of resources. So RPC, on the other hand, is all about functions. So we talk about like posting a message or deleting a message. So apparently Slack basically they have most of their APIs written in RPC style. So so what else they say here? He say so I think maybe Vijay would have more idea here. So basically the in this previous Ajax, right? So what is this? So web browsers are not the only type of client. Native app running on a mobile device or a desktop computer can also make network requests to a server. And a client-side JavaScript application running inside a web browser can use this request to become a HTTP client. So Ajax is, yeah, I'm not a front-end engineer, so yeah, what do we do with this Ajax? It's some kind of a blob that the client side, right?
It's asynchronous JavaScript. Essentially, what that means is that you can make a request to a server. It'll take some time. You don't know how long it's going to take. That's the asynchronous part, right? Like you're waiting. But on return of the payload, right, JavaScript will continue that function via callback. So that's kind of like the pattern, right? You make a call, the Ajax call with some code, and then you get back a response, and you can process that response. And in the meantime, JavaScript will just continue running other code that is synchronous until that callback returns. So asynchronous and synchronous code are two paradigms in JavaScript.
So just to add there, I had learned about it like 10 years ago. So briefly, I remember, I think the most common use case is when we load a web page, it loads the first snippet and then it keeps loading the rest of the page. I think Ajax is one of the most common use case there.
Does
Correct.
it keep on following about the changes also? I remember, like if there are any change, will Ajax behind the scenes, does it keep on calling for that?
So yeah, like essentially, if you use Ajax calls, you want to structure them properly. If you just make a whole bunch of random Ajax calls, then you can have, like with the web, right? Like if your intent is to kind of load things in an order or some kind of sequential order, you need to like think about how to do that with your Ajax calls. And so things like promises have been developed, right, over the last few years, with the improvement of the JavaScript language, so that you can kind of like create like a sequence where you make one Ajax call, and then on the success of that, you're able to like get the payload, do something with it, then make another call, then do something else. And if any of those then points kind of like fail, you can catch like the error point and kind of like say, okay, here's where the point of failure is. And then like even further today, like most people don't even use that. They use more of like this keyword syntax called async and await. And it's a little bit like simpler to read, and it also like helps catch errors faster. And so like it's kind of like funny, like how, sorry, I apologize about the noise. It's funny how like this has evolved so much from like back in the day where it was simple Ajax functions to like more, well, it's simpler now with syntax. So async and await. I can give some information about this. I'm just kind of like going fast through it.
In this chapter, the context is that if it's an Ajax call, the response is not a HTML. It is JSON that can be consumed by the JavaScript code.
Right.
So is that true? Okay. So basically there are two different types of endpoints that this basically the front end servers, basically the servers are exposing. One that returns HTML response, the others are returning JSON that this Ajax code can consume.
Right. So essentially, yeah, like you can make a HTTP request with Ajax, right? And then you can get back data in the form of, XML, JSON, another HTML document, whatever comes back from the other side, as long as, it's some kind of format that JavaScript can process, you should be good. You can accept any kind of like response back, but if the JavaScript, code can't process it, it's kind of useless.
Mm-hmm.
And then also the mobile clients too, right? Like they're going to be, it's not just JavaScript, because like web is just HTML, JavaScript, but like if you're using like iPhone or, Android, then they're going to also need to consume data that they are able to work with. And obviously Java and Swift can work with a lot more. But traditionally, I think it tends to be JSON, because JSON is like the simplest document to read.
Yeah. Okay, so that's an important distinction. So there are two types of data that's going over the network. One is over HTML, basically the HTML data, the CSS, the JavaScript, that kind of stuff that you need for rendering. And there are second type of basically the data that's that has this actual data, which is not HTML encoded. It's basically, it's just it's either JSON or XML that you were saying, right? So okay, so next they talk about what is microservices. I think microservices is just another name they gave to a service oriented architecture, SOA. So the basic idea is that you decompose a big monolith service into smaller services by area of functionality, and it helps with first of all maintenance. Like different teams can own different pieces of the service, and also helps with evolvability, and like also makes the businesses agile, because they can introduce features faster with microservices.
Yeah, can we take a minute though, like, because I feel like sometimes people kind of gloss over this. Like, again, this is like one of those things for me. What is a service? What does that mean to everybody here?
Service is a bunch of APIs.
But like more specifically, what does it mean? And then what's a microservice? Like,
Oh, what is a microservice is your question?
oh, like what's a service and then what is a microservice? Like how do they differ?
So that's what they're saying, right? The service is basically, yeah, I think if your question, what is a service? It's basically a set of APIs that return the data you need. So now microservice is a more specific use case of that. Basically it's a detail. Consumer need not like, if you're a client, you don't have to worry about that detail. For you, everything is a service. Microservices is a design, a design of the service itself, like to make it more maintainable. You can kind of decide to split up the service so that each one basically what happens is, like for example, there's front end, almost everybody has this, right? Like front end, back end, that it's already a different technology, but both are needed for a service to run, right? Like it makes sense to kind of separate those pieces as a separate team, and you can introduce, I mean, for any feature to if you are a service owner and you want to introduce a new team, yes, you might need to introduce changes in multiple dependent microservices, but the core technology used in each of these microservices could be completely different, and they can just work together and make the thing possible. Like for example, in for the front end, right, you could choose to use a JavaScript based service, and then for something that is more technical and not front end based, like for example, sign in OAuth, right, you could have a separate microservice for that,
right? Yeah,
which does not focus on rendering, it just focuses on security, getting the data and then persisting it in a secure fashion. So the focus of that technology, of that service, is entirely, security.
Yeah.
right.
So
Yeah.
I think to summarize, I think it is more like breaking down a service into smaller services, where each smaller service focus on a specific purpose.
Right. Yeah, essentially the service is like in the real world too, like somebody gives you something. Like if I say I want Starbucks, that person comes and gets me to Starbucks, like from Uber Eats or something, right? Like a service API that gives you like the data that you're querying for, a movie database service, or a car service. You can kind of plug in services like into your backend as you like. They're supposed to be like single units that essentially can be used for any application. They're entirely contained in one piece, right? And then a microservice is kind of like splitting that down even into like more fine-grained, right? Like they're saying kind of like simpler, smaller, like a login service, or because like you were saying, Amelia, too, like some of the services used to be a whole bunch of stuff together, right? Like a entire, API, right? Service. So the splitting and making
so
it
you can take
simpler is
advantage.
a
So
micro.
when you split these services, right, you can customize the choice of language according to the use case. Like you are an audio video processing service, and you can write in a language that's more low level. And if that microservice is more, application, like you can use Java, but like the same Java does not work great if you're dealing with audio video encoding, decoding. It's too slow. So
Right.
yeah.
There
Okay.
is another aspect as well, Amulya, the availability. So if let's say, just to break down Uber Eats, since Vijay just brought it up, at a high level, when we think of it, there is like the food preparation tracking, maybe there can be delivery, there can be payments, there can be user management. There are already so many high level like separate groupings we are able to think of. So if they are all microservices, even if the payment is down, the delivery is not down, the delivery can still be tracked. So your entire application is not down, some part is working, and you are still able to run your business.
Yeah, that's good insight. Yeah, for sure. Yeah, and then like if payment is down, you can kind of still track what happened on the delivery side and kind of reverse the accounting.
Another part is you can use different databases as per different microservices. Like some.
Good.
Yeah, that's one thing.
Yeah, I feel like that would be an interview question.
Yeah, that's if one of the services down or another service is being able to operate, it's as a system, it's a fault tolerant mechanism. High availability is more of I would say more instances where it's able to come up with the same response and SLA based on the load. The more load and still able to handle within that threshold limits, right? Fault tolerance and high availability are a little bit overlapping, but it's a different things. This is more of a fault tolerance mechanism.
Yeah, makes sense, Scott. Thanks for clarifying.
Good discussion. All right. I think we got.
What is a service-oriented architecture like, and how does it differ from microservice? I know what a microservice is very well, but how does it differ from SOA?
It's a precursor to microservices, if you will, right? Yeah, it's the parent, and microservice is just the children of SOA. Yeah.
Yeah, they say in that first sentence, right? They say it's just SOA is refined and rebranded as microservices. So it's the same thing. So yeah, we can just finish off that just until web services, right? So what they say in the next sections is that, so you with databases, right? Basically when you query, the databases have to support a generic query form, because the clients can request whatever they might have, like 100 different query parameters. So when you're writing a generic service like database, the queries are more open-ended, but with services, with web services, you don't have to, you can basically define what is a legitimate request. You can basically define that, and that's what they say. A key design goal of microservices is to make application easier to change and maintain by making services independently. Yeah, that's what Subha was saying, right? So you can independently deploy, evolve, and maintain, and we should expect old and new versions of the server. Yeah. So with microservices, it's important that we maintain compatibility between different versions, because I think it's not a microservice specific thing, right? If you are a service, you should expect different types of clients out there in the world. So so I think that's not, oh, you are ahead of me, Vijay. I'm still on the previous chapter.
Oh, you're still on the previous page. Oh, okay. I was just a little bit. Okay, so
Yeah.
you're probably right here actually.
Right. Yeah. So basically, they're saying they say that key design goal of a service-oriented microservices is to make application easier to maintain and change. And then here they're saying, yeah, I think it's not. That's what I got confused with. So basically, he says we should expect old and new versions of servers and clients to be running at the same time, and so the data encoding used by servers and clients must be compatible. Yeah, I mean, what is it about microservices? Yeah, because there are multiple clients now. Your a service client is another service, right? So, and there could be multiple services consuming the same data, so you have to make sure that whatever you're sending out is compatible with all the clients, which could be the actual end user client and the other services which are consuming your data. So do we want to do the next section, or?
I think we can actually kind of stop like here, because like this section is going to continue on. It's going to be kind of long. But I did want to just kind of say, like, to your point, right? Like, and I kind of know this, like, just from my own experience, right? Like, this is kind of really important here, right? Because like, when you start supporting multiple clients, and you have to, and it has to be compatible across like many different, clients and all that, you start getting like kind of very complicated code at some point. And so that tends to be a bottleneck for some companies, right? Like, because if there's stuff that doesn't work on one, deployment versus another, or there might be like some issues. If you make a fix, it could break other endpoints. So this is something that has to be really, really thought in and well done. Otherwise, like, essentially you lose your job. Because like it costs a lot of money, but this is a real thing. It's not just one person like who makes this mistake. It's like, a team,
Yeah,
so
the way to guard against that is to have integration tests running all the time, so
yeah.
you're breaking your clients before it gets rolled out. Yeah,
We should discuss this a little bit more, like maybe just kind of like deep dive into this area at this point, but I'm fine like taking it one day at a time.
Yeah, actually I posted the Notion link. I summarized the REST and RPC and GraphQL ways of designing APIs. If you go all to the bottom, I put all a reference also. So if you guys find more stuff, feel free to add it, but then it's a summary. Yeah, so the that I have to put, yeah, but this is the REST. So what are the pros and cons of the REST API design? And
It's great.
Yeah, so it's a 10-minute YouTube video, which kind of had maybe if you have pictures and all, maybe it's easier, but
Yeah. I mean, I can fill in some of that too, because you did a lot of the reading today and you did the notes as well. So I can kind of like help with this part too. So I'll give you some notes, and I'll also like include the links that we talked about today, including like the Alex Shu gateway pattern, the espresso stuff from LinkedIn. Yeah, and then anything else that I have up here in terms of like whatever's relevant. GraphQL, I guess that would be like the other one. If you have, a couple hours this weekend, right? Like, or, like a couple hours the week, don't try to cram everything, try to find a course that's like 3 to 4 hours and just get like the high level on what GraphQL is, because then you'll be in good shape for that technology. Maybe also review like just what a microservice is and a service, like what are the standard definitions for that, and then maybe this pain point here, like what are some ways to like kind of support multiple things.
So why are you going through the courses, Vijay? Like what is it that you're going to get? Because after 10 days, if you don't read that, you will forget all that technical details anyway.
Oh no,
So-
like, so I actually have a framework that I use to remember stuff. And so like for me, like I don't usually forget. And it's kind of like based on yours, right? You're using this format where you're using Notion and then you're writing kind of like to the left. And I think that there was a study pattern that I remember from that, like, what was it called? It's the Cornell note-taking method, right? Is that correct?
Yeah, this one. Yeah.
Yeah, you're using Cornell's note-taking method, right? And then I also kind of use another method, which is called, like, I always say explain it like grandma, but like there's an actual term for it. But it's like I think it's called the Feynman or Furman technique. Essentially, if you can take a big, dense piece of like documentation or some kind of, notes here, and then you can explain it to somebody who's non-technical, like your grandma. And I think it's called the Furman technique or the Feynman technique. I'll have to kind of just double check. I think I wrote it in here anyway. Then you know it, right? Like, so that's the thing, right? Like if you know it, and you can explain it to somebody else who is non-technical, in like your grandmother, and they can understand it too, then like you've achieved mastery over it. And so for me, like I've been just kind of like focused like this past year, just kind of like saying, okay, what should a full stack developer know? And like I made very much like a data structure, right? Like a graph of things that I want to know, right? So here, like the things that I want to get good at. So this is why I even like started networking, talking to people and learning, because I want to get good at algorithms, data structures, LeetCode, design patterns, solid, and then system design, right? And then just have better understanding of these languages. But of course, keeping it all in your head is very difficult, but we have a very cool tool called a computer, which can store information your brain can't keep up with. So just like a disk seek, right? I can't remember all this in my memory, in my head, but every time I want to make data fetch, I can just go to my well fine-tuned notes and go, oh yeah, that's what this is. And in times of like interviews, I can just kind of like ace them. And then it's not a problem for me. Or if I have to like write code, I can go, that's where this thing was, right? In my B tree that I created in my head, right? Or my notes. So that's kind of like how I'm doing it. Real world system design.
That's impressive. Thanks for sharing it.
Yeah, maybe it sounds more, and actually it's funny because like I was starting to say this like on LinkedIn, and I was like, you know what, I better be careful, because somebody like said, hey, I think you're in the wrong seminar. So like I started thinking, like if I start explaining stuff like this in this way, like people are going to think I'm a lunatic, or really like either I'm really, really smart or I'm a lunatic. But like that's my method to madness anyway.
Yeah.
So.
Yeah, but like also you should not be bogged down with details. I mean, unless, yeah, I think this book is a good high level introduction. But like, I mean, for somebody like me, if you talk about Avro, a lot of it is just goes through because I don't have a use case for it in real life.
Yeah.
And it's kind of, it won't stick. I know for sure.
Yeah, and nobody expects you to in the real world, honestly. Like you're not, like, even for me, right? Like somebody like me, like when people talk to me, like I can tell them I know so much stuff, right? Like in an interview. And at the end of the interview, like they'll still say, oh, so you do front end, right? And I'll be like, I just told you like what all I can do, and you still think I know just JavaScript and React. But I'm okay with that. Like I am not like sitting, I mean, if you're going to pay me, right, and you're going to give me a job, fine, I'll do it, right? You're going to pay me some money, I'll do the job. And if it's the money I want, I'll do it. But like for me, like my goal is to kind of like continue to layer upon layer. And yeah, I'm not like sitting there saying I need to like master Avro just to be like better the next day. It's not for that. It's just better understanding. And I think, so this is one more thing that like I kind of, and I might be going way over time here, but I'll just kind of give it a small like summary here. But like, I've always been curious, like what's the difference between someone who is like a genius and then somebody who is just like studying their ass off, right? Like somebody who's just like working hard. And I think like the thing is like the person who works really, really hard is just like they're kind of like in panic, right? Like they're like, oh, I have to work hard. I have to really, you know, like study hard so I can ace this interview or I can get a job or something like that. There's always like this constant stress. Whereas like a genius, like they kind of like get mad at the genius because it feels easy to the genius, right? Like genius is kind of like able to always like keep up and they're never stressed. They're just happy, right? And so like I was like thinking like, what is this thing? Like why is it like that? And in my mind, I think like I may have come close to the answer. I don't think maybe I've got the entire answer here, but like a genius is just naturally curious. That's it. That's what I've observed. Like all the people who I've ever like noticed in my life who were super smart, like way smarter than like, you know, just tons of practice that I could do, right? They don't find this like annoying or boring or anything like that. They just kind of like get joy out of it. And like, they're fine with being self-paced, but they just naturally bring it. Like they're not actively thinking, oh, I need to practice. It's just like, I'll go learn Avro today. Oh, I'll go learn this thing. I didn't know that. And they just kind of layer it over. And then they just have methods already built in to be able to keep up with their notes. So they're not even like thinking about it or stressed out. And so then it just makes them happier and more joy. And I don't know. So like in my mind, I'm trying to build like this natural curiosity.
Yeah, I think what Amulya was trying to say is if like for interview, they don't go into these details, but I think what Vijay, you are saying is it helps you personally to grow.
Exactly.
It perfectly makes sense. Yeah, they're basically two different parallel tracks.
Yeah.
Not learn on a deadline. That you should not do. So that's if you learn on a deadline, right? It's going to be stressful and you're going to lose it anyway. So you should take your time, kind of just be curious for the sake of it and just make sense and understand how like develop an intuition. Intuition is not is something that does not require this, you know, recollection, remembering. You just know what works and what doesn't work intuitively.
Exactly. That's what I'm trying to build for myself. The more I see this and like learn it, the more I just kind of feel like, wow, this is cool. It makes more sense in the whole big picture. And, you know, like I can keep going on, right? Like lately I've been buying like all the old 90s video games and trying to restore them. And I'm like, oh, I wonder how the PlayStation 2 does disk seeks. Like it goes in my mind, like that kind of thing, or the Dreamcast or whatever, like all these video game systems. I'll show you my room sometime. But like, yeah, just in my mind, I always think about these things. Like, it's not just like, oh, I'm preparing for a test, if that makes sense.
But it really helps in long term. I can attest to that, Vijay. I've seen whoever have had that attitude, they have really grown in their career and life because they can just absorb things in anywhere just because back of the mind, they know so much.
Yeah. It's crazy, you know, and again, I'm not trying to like keep you guys here. If you have to drop, you have to drop.
Yeah.
Just like essentially, you know, I just find it very fascinating and it's fun. Yeah, that's all.
For sure.
Okay. Thank you all, and I will see you.
Hey guys, I wanted
next...
to
go
introduce I wanted to like can we discuss about something called Envoy proxy? I'm using it currently. And I think it is a must know for everybody in this group. It's really a very recent technology. I would like to spend like 10 minutes or 5 minutes next time discussing about it next time.
Yeah, absolutely. What is it called again? Could you say it?
Envoy proxy.
Envoy proxy.
Envoy, ENVOY.
Envoy proxy. Sorry, I have a hard time hearing sometimes. All right, so Envoy.
Yeah.
It's a service mesh.
Yeah, service mesh, yes. Yeah, I'm using
it's
it.
L4 level service mesh, yeah.
Yeah. It's good too. It's pretty nice. Yeah. So I would like to discuss a little more details about it.
Okay, yeah, for sure. Yeah. All right, you can do that next week, Wednesday. And if you're like, no, I really want to do it early, we just send some messages here or Discord too. That's totally fine.
Yeah. So bye.
Okay, see y'all. Bye. Thank you.